Alright, welcome to this video. In this video we're going to talk about parallel and perpendicular lines. We're going to start with a discussion on the definitions of each, and we'll look at some example slopes because slope is the key here with parallel and perpendicular lines. And then we'll work through some various problem examples and the types of problems that you will often see related to parallel and perpendicular lines and how you will handle those. So let's start with really looking at the definitions of parallel lines. Parallel lines have the same slope. So those students usually don't have a big problem with parallel lines. The slopes are the same. That's pretty straightforward. And it makes sense. If you have the line, if we had a y-intercept here of 2, and we were had a slope of 2, so we're going up 2 and over 1, and up 2 and over 1, up 2 over 1. Alright, so the equation of our blue line here is going to be y equals 2x plus 2. Alright, so we can kind of sketch that in here like this. Alright, and then if we had a parallel line to that, an example would be y equals 2x plus 4. So we have the same slope here, 2 and 2, right? That's what our definition says. So we need the same slope in both cases. So in this case, for this line here, we're going through a y-intercept of 4. So that's 1, 2, 3, 4 here. And then we're going up 2 and over 1, up 2 and over 1, and up 2 and over 1. Alright, so our line is somewhere in just like this. Alright, so that makes sense that these two lines are parallel because they have the same slope. Now my drawing's not very good there, but you get the idea. These two lines have the same slope, so they will never cross. If this blue line had even a little bit steeper slope than 2, just a little over 2, eventually somewhere up here they're going to finally cross. But when the slopes are exactly the same, they just run parallel to each other forever. In infinity this way and infinity this way. Okay? Alright, so that makes sense. Most students don't have an issue with that. Where students seem to struggle is with the perpendicular lines. And perpendicular lines have slopes that are opposite reciprocals, sometimes called negative reciprocals, sometimes called negative inverses. However your teacher describes it, the bottom line is the signs are different and the fraction is turned over. That's basically what it means. So let's look at some examples of what would be considered perpendicular slopes. So let's just make a table here. So these are perpendicular lines and the slopes that go with them. Perpendicular. Alright. So I'm just going to make a list of slopes here. So let's say we had a line that had a slope of 3 over 2. We had a line that had a slope of negative 2. We had a slope of a line that was negative 1/5. We had one that was plus 5/3. We had the slope that was 6. Alright? So in green here, we'll make the perpendicular slopes to all of these lines. So 3 over 2, when we take the opposite reciprocal, the first thing that we have to do is change the sign. This opposite part right here means change the sign. That means opposite sign. So if this is positive, our new slope has to be negative. The reciprocal part, this part right here, means to take this and flip it over. The reciprocal of a fraction is you take the denominator becomes the numerator becomes the denominator. So the bottom number comes on top, the top number comes on bottom. So when we do that, with this, we're going to have 2/3. Instead of 3/2, we're going to have 2/3. And we already changed the sign. So these two slopes would be perpendicular slopes. Again, slope is the key. That's the whole key to parallel and perpendicular lines, are the slopes and how they relate to one another. Alright, negative 2. Remember that we can rewrite negative 2 as, I'm going to do this in blue, negative 2 is the same thing as negative 2 over 1, right? Any whole number can be rewritten over 1 so that we can put it in a fraction. Okay, so that's the way you handle these whole numbers. Now, the opposite part, first we've got to change the sign, so we're going to be a plus here. I'm going to leave the plus. The plus would be implied if we didn't list it, but for the sake of this example, I'm going to write the plus. Okay, then the reciprocal part means turn it over. Bottom number comes on top, top number comes on bottom. That's what a reciprocal is. So that gives us 1/2. So plus 1/2 here. Okay? Alright, now this -1/5 is already written as a fraction, so we know it's going to be a plus because that's the opposite part. It's the opposite sign of this. And then we turn this over. So the 5 comes on top, 1 comes on bottom, and that becomes plus 5/1, which is the same thing as 5. Okay, so the perpendicular slope to -1/5 is 5. A slope of 5. Alright, 5/3. So first thing we do is change the sign. Opposite sign. It's got a plus here, so we will now have a negative slope. We will turn the fraction over, so bottom number comes on top, top number comes on bottom, so that makes it -3/5. So the slope that's perpendicular to a slope of 5/3 would be -3/5. Alright, 6, we have a plus 6, so the opposite part means change the sign, so our new slope for a perpendicular slope would be negative. 6 can be rewritten as 6/1, so we can write it as a fraction. Then we're going to take the reciprocal of 6/1, bottom number comes on top, top number comes on bottom, and that gives us -1/6. Okay, so here are several examples of perpendicular slopes. The perpendicular slope to 3/2 is -2/3. The perpendicular slope to -2 is plus 1/2. The perpendicular slope to -1/5 is a plus 5. Perpendicular slope to 5/3 is a -3/5, and the perpendicular slope to 6 is -1/6. All right, so let's. I'll pause the video here, and we'll look at why this makes sense that you would need opposite reciprocals to make perpendicular lines. So let's look at that. All right, so for an example, let's use these slopes right here, the 3/2 and the -2/3. So let's make up some lines. Let's say we had the line y equals 3/2x minus 5. And our perpendicular line to that we know has a -2/3 slope, so we'll say that's -2/3 plus 3. Alright, so now the first thing that we need to do is graph each line. So let's graph this line in blue. So we have a y-intercept. Remember, when we graph these lines, start with the y-intercept and mark a point there. So -1, 2, 3, 4, 5. That's the easiest thing to do. Alright, now take our slope. 3/2 means up 3. So we're going up 3 and right 2. So we're going up 3, 1, 2, 3 over 1, 2. Another point, up 1, 2, 3 over 2. 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 Alright, I'll try to fit a line in here as best I can. Alright, so here's our line that is 3/2x minus 5 right here. Alright, now let's graph our line in green. And we have a -2/3, so that means we're going down 2 and right 3. That's what our slope means. We're going to start at our y-intercept of 3. 1, 2, 3. Alright, so there's our y-intercept. Now let's think about this. The opposite part means change the sign. So if this blue line is a positive slope, which we know it is, it only makes sense if we're going to be perpendicular to this line that we have to have a different sign. If this line is positive, which we've identified, then we know that to be perpendicular to this and make a perfect 90-degree angle, make a perfect plus between this blue line and the green line we're about to draw, this green line's got to come through here like this. It's got to have a negative slope. So that's where the opposite comes from. All right, now let's put some points in here. So we're down 2, right 3. Down 1, 2, right 1, 2, 3. Down 2, right 1, 2, 3. Down 2, right 1, 2, 3. Down 2, right 1, 2, 3. So we'd be out here somewhere. Alright, let's try to fit this in. Not perfect, but you get the idea. Alright, so these two lines will be perpendicular. We were saying we have right angles here. That's the symbol for a right angle. Perfect plus. It's a perfect 90-degree angle between those two. Okay? Alright, let's look at some other example problems and the way that you would handle those. Alright, here we have a common type of problem where you're asked to determine whether the two lines given are parallel, perpendicular, or neither. So we have two lines here, that'll be example 1, two lines here, that'll be example 2, and two lines here, that will be example 3. So we'll look to determine whether the lines are parallel, perpendicular, or neither. Okay, so in the beginning of the video, what did we talk about? What is the key to parallel and perpendicular lines? It's the slope, right? The slope. The slope is the absolute key. That's how we determine if two lines are parallel, perpendicular, or neither. Now, I'll have students come in and they'll try to put the two lines in a calculator and tell if they're parallel or perpendicular, and you can't tell from looking at your calculator. Not 100% of the time, because two lines that just have a slope that's a little off may look parallel on your screen, but they'll eventually cross out of your window. So you can't trust that calculator. If they're perpendicular, your calculator is a rectangular window, not a square window. So it can look like two lines are perpendicular when they're really not. So you really can't trust that calculator. Okay, so you've got to be able to get the slope of the two lines that you're looking at in order to determine if they're parallel or perpendicular. Alright, so let's do that. We've got standard form lines here. So what must we do to identify the slope? We have to get y by itself, so that's going to be our first step. So with this line, we have 2x minus 8y equals 7. So we'll subtract the 2x, negative 8y equals negative 2x plus 7. Then we'll divide everything by negative 8, divide by negative 8, divide by negative 8. Now, a shortcut to all of this, you don't even need to worry about what the y-intercept is right here. We don't even have to worry about that. We're only concerned with this part right there, the slope. Alright, so we'll strike this out and we get y equals 1/4 x. We'll go ahead and do this even though it's not necessary, minus 7/8. Okay, so here's the key, right here, our slope, 1/4. Now let's try this other line. Negative x plus 4y minus 1 equals 0. Okay, we'll add 1, get negative x plus 4y equals 1. Add the x to both sides, add the x to both sides, and we get 4y equals x plus 1. I'm just rearranging that a little bit. Divide by 4, divide by 4, divide by 4. We get y equals x over 4 plus 1/4. Now, what is x over 4? I'm going to write this off to the side. Remember that x over 4 is the same thing as what? Well, what number is implied to be in front of this x? Well, that's a 1, right? So that's the same thing as 1/4 x. Alright? So I'm going to write it that way. 1/4 x plus 1/4. Alright, so here's our slope here. So we have 1/4 and we have 1/4. So what does that mean about those two lines? That means that they are parallel, right? They have the same slope, so they are parallel. Alright, so I'm going to put a big parallel sign right there on that one. Alright, let's look at this next example. 3x minus 2y equals 7, 6x plus y equals negative 8. We're going to determine whether these are parallel, perpendicular, or neither. What's the key? Slope. Slope. We've got to get the slope of these two lines. Of course, they're in standard form, so we've got to get y by itself. So we have 3x minus 2y equals 7. Subtract 3x, subtract 3x. Cross that out, bring everything down. Negative 2y equals 7 minus 3x. Divide by negative 2, divide by negative 2, divide by negative 2. Strike this out. Y equals negative 7 over 2 plus, we've got a negative divided by negative, plus 3 over 2x. Okay, here's our key right there, that slope. Okay, let's do the next one. 6x plus y equals negative 8. Okay, subtract the 6x, we'll shortcut this, y equals negative 6x minus 8. Right? Okay, so we have a negative 6 slope and we have a 3 over 2 slope. So negative 6 and 3 over 2. Are those the same? No, so parallel is out. Alright, I'll erase that so we don't get confused, but parallel is out. Okay, and now we're going to look to see if they're opposite reciprocals. Well, what's the opposite reciprocal of 3/2? It would be turn it over and change the sign, so it would be a negative 2/3. This is definitely not negative 2/3, so these are neither. let's box this parallel in. We said these were parallel. That's the final answer and what we were looking for. Alright, this last example. Alright, so we have first line here. What are the keys? What are the keys for these two lines to tell if they're parallel, perpendicular, or neither? The slope again, right? We've got to find that slope, so let's do that. We have 4x minus 12y equals 2. Whoops, equals 2. We'll subtract 4x from both sides. Subtract 4x. That gives us negative 12y equals negative 4x plus 2. I'm just going to go ahead and rearrange that a little bit. Divide by negative 12, divide by negative 12, divide by negative 12. Here's what we're looking for right here. So we have, I'm going to scoot this over so we've got more room. Y equals negative 4 divided by negative 12 is a plus positive 1/3. Negative 4 divided by negative 12 gives us a positive because it's negative divided by negative, and 4/12 will reduce to 1/3. So it's 1/3 x minus 2 over 12 becomes 1/6. Okay, but here's what we were looking for, that 1/3 right there. And if we're not sure about that, we could always pull up our calculator and do negative 4 divided by negative 12, and then math enter, and it would end up giving us that 1/3. All right, so this other line I'm going to have to move down here. I'm running out of room over here. So we'll start here. 6x plus 2y minus 7 equals 0. So we're going to add 7. We get 6x plus 2y equals 7. Don't let this minus 7 here mess you up. I mean, our goal here is to find the slope, so we've got to get y by itself. So we've got to get everything else over here away from y. And so that's why we went ahead and added 7 there. We're going to subtract 6x from both sides. Subtract 6x. Running out of room there. We'll get 2y equals negative 6x plus 7. Okay, divide by 2, divide by 2, divide by 2, and we get y equals negative 6 over 2 is a negative 3, negative 3x plus 7 over 2. Okay, so the slope here is negative 3x. So we have a 1/3 and a negative 3x. So let's see. Are they the same? Absolutely not. So it's definitely not parallel. Let's see if they're opposite reciprocals. So we'll look at this 1/3. So let's see. If we had the opposite reciprocal of this, it would definitely need to be negative, and we would have to turn this over. So the bottom number comes on top, top number goes on bottom, and that would be a negative 3 over 1, which would equal negative 3. And that's what we have here. So we are definitely perpendicular. So we'll put the perpendicular symbol here and box this in. Alright, so let's look at a couple more examples here. Alright, just 2 more examples and we'll call this video good. Alright, so here's another example type of problem that you would see in relation to parallel and perpendicular lines. So the basic instructions are: write the equation of the line that matches the situation below. This first situation right here, do this in blue, says the line that passes through 4 comma negative 2 and is parallel to 4x plus y equals 11. Alright, so we need to be parallel to this line. So what do we need to get out of this line to figure out how what needs to happen with our line to be parallel to this? Well, what is the key? What is the key to parallel and perpendicular lines? It's the slope. It's always the slope. So let's get the slope out of this line. So we have 4x plus y equals 11. So we're going to subtract 4x from both sides. Subtract 4x. And we'll get y equals negative 4x plus 1. So here's all we need out of this line. The slope right here. Negative 4. So we know for our line we need an m equals negative 4 and through the point 4 comma negative 2. So we can use point slope here or the y equals mx plus b and solve for b, which is the method I'm going to use here to save time, and we can solve it. So here's our x, here's our y, and of course here's our m. So now we just fill in our y equals mx plus b, solve for b, and then we've got it. Once we have b and we have m, we can write the equation of any line. Alright, so we're already given m, so we just need to find b here. So we say negative 2 for y equals our m, negative 4, times the x that we're given here of 4 plus b. Negative 4 times 4 is negative 16 plus b equals negative 2. We want to get b by itself. We're solving for b, so we're going to add 16, and we get that 14 equals b. So once we have b right here, and we have m right here, then we've got it. We just write the equation. So it's going to be y equals negative 4x plus 14. Alright, so there is the equation of the line that fits this situation. Passes through 4 comma negative 2 and is parallel to 4x plus y equals 11. Alright, I'm going to break the calculator up so that we can prove that this is true. Alright, so we've got our calculator pulled up here. And we want to make sure, basically, that we know that our original line had a negative 4 slope. We have a negative 4 slope, so we know that's right. We know that they're going to be parallel. So let's put this line in. Let's clear these two out. So we'll put our original in, negative 4x plus 1, and the most important part is to put our second line in, negative 4x plus 14. So we can look at these lines and we tell that they're definitely parallel because they have the same slope. So that part right here we've checked off. Now we need to make sure that the point 4 comma negative 2 is on our y2 line here, on our negative 4x plus 14. And if that's true, then we know we did it correctly. So we're going to go in our table and we want to find when x is 4 right here. When x is 4, y needs to be negative 2. So let's bring this in here. And we see that we have the point 4, negative 2 here. So when x is 4, y is negative 2. So that's the point 4 comma negative 2, and that's what we wanted. So that checks. We know we did this right. All right. So on this one we're passing through the point negative 1 comma 9, and we're perpendicular to this line. So what's important about this line that we need to find? The slope, of course. The slope. The slope is the key here. So we need to find the slope of this line so that we can find the slope of the line that we need to write the equation for. So what do we have to do with this? We have to get y by itself. So we have negative x plus 5y plus 8 equals 0. Don't let this 8 scare you. We need to get everything over here on the right side and get y by itself. So that's going to give us negative x plus 5y. We subtracted 8 from both sides, so that gives us negative 8. 0 minus 8 is negative 8. We're going to add x to both sides, and we're going to get 5y equals x minus 8. Just rearrange that a little bit, put the x first. Divide by 5, divide by 5, divide by 5. That gives us y equals, x over 5 is the same thing as 1/5 x minus 8/5. Alright, what we need out of this is the slope. Right here, 1/5. Now we need to be perpendicular to this 1/5 slope. So perpendicular to a 1/5 slope, let's see. We need the opposite reciprocal. So the opposite of this sign would be a negative, and then we need to turn this thing over. So the bottom number comes on top number comes on bottom, and that gives us an m of negative 5. So our m for our line needs to be negative 5. And then we're already given an x and a y here, so we're going to solve for b, and we're going to put it in our y equals mx plus b form. Remember, we were given y here, we're given m here, and we're given x here, so we're looking for this b. That's what our next step will be. So let's fill this in. 9 equals y, 9 for y. We're going to plug in a negative 5 for our m. We know our slope needs to be negative 5. Our x was given to us as a negative 1 plus b. So we're solving for b. Negative 5 times negative 1 is 5. So 5 plus b equals 9. Then we're going to subtract 5 from both sides. 9 minus 5 is 4, so 4 equals b. Now we've got it. We have our b here and our m here. So now we can write our equation. Y equals negative 5x plus 4. Alright, so negative 5x plus 4 is the equation of the line that is perpendicular to this line and goes through this point. Now let's bring our calculator up over here and check it. Alright, so we have a negative 5x plus 4, so we need to put that in y equals. Let's clear this out. And we know that we did our slope right because our original line was 1/5. We've checked that, so that should be a -5 to be perpendicular to it. So now we just need to make sure that this -5x plus 4 goes through this point, -1, 9. That's our last check. -5x plus 4. Go in our table. We're looking for when x is -1, and there it is. We've got it right here. Move this up. So when x is -1, y should be 9, and it is right there. We have the point -1, 9, so we know we did it right. Alright, that wraps this video. I hope it helped. Make sure and subscribe to the YouTube page, post comments, ask questions. I'm here to help. See you in the next video.